Logic gates are devices that perform logical operations on one or more binary inputs and produce a single binary output. They are the basic building blocks of digital circuits and systems. There are 7 common types of logic gates. AND gate produces a 1 output only when both inputs are 1. Otherwise, it produces a 0 output. OR gate produces a 1 output when at least one of the inputs is 1. Otherwise, it produces a 0 output. NOT gate produces the opposite output of the input. If the input is 1, the output is 0. If the input is 0, the output is 1. NAND gate produces a 0 output only when both inputs are 1. Otherwise, it produces a 1 output. It is the inverse of the AND gate. NOR gate produces a 0 output when at least one of the inputs is 1. Otherwise, it produces a 1 output. It is the inverse of the OR gate. XOR gate produces a 1 output when the inputs are different. Otherwise, it produces a 0 output. It is also known as the exclusive OR gate. XNOR gate produces a 1 output when the inputs are the same. Otherwise, it produces a 0 output. It is also known as the exclusive NOR gate. It is the inverse of the XOR gate. Logic gates can also be combined to form more complex gates such as AOI and/or invert and OI, OR and invert gates. Logic gates are used in many devices and applications that we encounter in our daily life. Some examples are calculators. Logic gates are used to perform arithmetic operations such as addition, subtraction, multiplication, and division. For example, a full adder circuit can be made using XOR and OR gates. Alarm systems. Logic gates are used to detect and respond to different conditions such as fire, smoke, motion, or intrusion. For example, an AND gate can be used to activate an alarm only when both a smoke detector and a heat sensor are triggered. Traffic lights. Logic gates are used to control the sequence and timing of the traffic lights at intersections. For example, a timer circuit can be made using NOT and OR gates to switch the lights from red to green and vice versa. Computers. Logic gates are used to build various components and functions of computers such as processors, memory, registers, counters, encoders, decoders, multiplexers, and so on. For example, a microprocessor can be made using thousands of logic gates to execute instructions and perform calculations. Digital electronics. Logic gates are used to construct circuits that perform logical operations on electrical signals, such as voltage or current. These circuits are the basis of digital devices and systems such as communication and navigation, avionics, microprocessors, memory units, registers, counters, encoders, decoders, multiplexers, and so on. Logic gates are both hardware components and software. Hardware logic gates are physical devices that perform logical operations on electrical signals, such as voltage or current. Software logic gates are programs or functions that perform logical operations on binary data such as bits or bytes. Hardware logic gates are faster and more reliable than software logic gates, but they are also more expensive and less flexible. Software logic gates can be easily implemented and modified using programming languages, but they are also slower and more prone to errors. Some examples of hardware logic gates are transistors, diodes, resistors, and integrated circuits. Some examples of software logic gates are Boolean operators, conditional statements, and logic gate simulators.